In this video, we'll cover the basic application of F equals ma to tension in a string. Suppose a block is hanging down and is still. Well, for any object, the net force on it always equals its mass times its acceleration. And if the force pulling down on the object is mass times the acceleration due to the force of gravity, then there must be an opposite force pulling upwards. We call this opposing force here tension, and we say that the string has tension T, and this tension, like any force, has units of newtons. Now let's examine three basic scenarios in which string tension arises. First, if the object is still, the tension must equal the object's mass times its acceleration in the opposite direction, which will usually just be g. Second, suppose a person comes along and pushes up on the block, but not enough to actually move it. In terms of our equation, that means an F sub p for person term will get added in here. If A is still 0, when you do the algebra here, you'll see that the tension is now F sub g minus F sub p, or less than before. As you'd expect, tension does decrease. Third, suppose a person now pulls up on the string. Well, two things will happen simultaneously. One, T, the tension in the string, will increase. This should be intuitive, since there's a person pulling on the string. And two, the block will start accelerating upwards. A will go from 0 to greater than 0. And in terms of our equation, this makes sense. String tension problems can get complicated, but now you understand a few basics.